If you are struggling in chemistry and you feel like you're getting the chemistry right, but you're getting the math wrong, this is a video for you. I'm going to talk about two things. First of all, is the two kinds of math we typically see in chemistry. And then I'm going to highlight that you might be using your calculator wrong. So I want to make sure that you know how to use your calculator correctly. Importantly, using a key like this exponent key, or you might see it as this EE key, or on a more sophisticated calculator, it might actually show up as the times 10 to the key. So understanding how to use scientific notation, the common mistakes that students make with scientific notation, and how to make sure to use your calculator correctly so you don't keep making these mistakes. Okay, first thing is just to highlight the differences between math and chemistry. Now, obviously, you're taking a chemistry class and you need to understand the chemistry, but you may be struggling with the math so that you're not able to demonstrate that you truly do understand the chemistry. So I'm going to highlight that there's two kinds of basic math that we do in chemistry. The first is we solve algebra problems. And that's where we basically are going to have an equation. We're given lots of pieces of information that we generally are using that equation to solve for one unknown. So we have an equation, and we're basically going to be solving for one variable. So solve for one variable. Now, I will highlight that there are more challenging problems where you might have multi-variable problems. Don't worry about that. As long as you have one equation for each variable that you need. So for example, if you have two variables, two unknowns, as long as you have two equations, you can actually solve those kinds of problems. That's more of an advanced skill. I'm going to focus right now on how to think about solving one equation for one variable. So again, just highlighting that if you have two variables, that's okay, as long as you have two equations that allow you to relate those different variables. So I'm going to link to another video that you can use, which will help you with algebra. Again, I'm a chemistry teacher, not a math teacher, so I'm going to give you some good resources that might help you with algebra. But again, highlighting the key with the algebra is that you need to isolate the variable, what you're looking to solve, on one side of your equation. And then the other side of the equation is going to be your constants. So you're going to have your constants that you're going to combine on the other side. Okay, so here's some common places where students can make mistakes, right? You have to think about what kind of mathematical operation you're doing. If you need to move a constant to one side or the other, are you going to be adding or subtracting that constant to both sides? Remember what equations really are. Equations are things that are equal to one another. So as long as you can do the same thing to one side of the equation as you do to the other, you've maintained that equality. So you can add or subtract the same thing to both sides, and that will maintain your equality. You can multiply or divide on both sides of the equation. So these are the tips and strategies and tools you will use to make sure that you can isolate all of your numbers, your constants on one side, and you're left with just your variable on the other. But this is a place where students commonly make mistakes. Another place that they often commonly make mistakes is not understanding the differences between log base 10, which is log, and natural log, which is ln. And then also noting that you have the inverse of these functions. Like the inverse of subtraction is addition. The inverse of addition is multiplication. Understanding that the inverses that you have for these processes are important to sort of connect correctly. So algebra is, again, a very common thing that we'll use. We've got equations that we use in chemistry. And again, we're not talking about sort of a balanced chemical equation. We're actually talking about equations like PV equals nRT, or an equation for how we figure out an electron is jumping around. The other common tool that we use to do math in chemistry is unit conversion. And again, I do have a number of videos that I will link to as resources for you to think about how to do unit conversion. So this video is not about telling you how to do unit conversion, but reminding you that that is an important sort of math skill that we need to figure out. So here's some things, just typical strategies to think about with when you do unit conversion. How I like to highlight to students is you start with a piece of information that you know. It's going to be something that has certain units with it. And you have your answer, someplace that you want to go. And again, you have units for that answer. And the goal is you are going to be connecting these pieces together. I call this the walk that you go through, where you are going to be using unit conversions essentially to change the units. This is not unlike the math that we have here, where you have an equation. You have two things that are equal on one side, and you have to do mathematical operations to maintain that equality. The idea with unit conversion is we're not changing the identity of what this is in terms of what its absolute sort of truth is. We're just changing the units that contain it. So a couple of strategies to sort of think about here. I always encourage students to start with something that probably is a measured quantity. Because unit conversion is multiplying things together, the order of operations doesn't really matter, but sometimes trying to figure out where to start your walk can be challenging. So sometimes it's using sort of a measured quantity. Oftentimes a single unit quantity is a place to start, and then you use unit conversions to sort of interconvert those pieces. Another thing that I want to remind students to think about, and this is a place that they can get into trouble when they're doing unit conversions, is every single quantity that we have in chemistry is going to have some type of a numerical unit or a value with it. So we're going to call this number. This is a numerical value. It's going to have a unit with it. And then it's going to have an identifier or a qualifier. Who does that belong to? So as an example, you might think about having, let's say 10 grams of water, right? It's important that you have a quantity, that has a value with it, so we know how much, but it also has a unit and how much and who it belongs to. So having all three of these pieces together, students tend to get a little bit lazy and take shortcuts, but when you do that, you find that you might have challenges using the correct unit conversions that you need to have. And I'll get to this in a sample problem that we're going to work through to practice using our calculators in a minute, but there's typically three kinds of unit conversions you'll be using. Prefix conversions. These are things you need to know. This is, for example, converting liters and milliliters or grams and kilograms, right? Those are prefix conversions that you need to know sort of the relationship between those. Then we have English to metric conversions. These are sort of the weird ones that maybe we're talking about something with grams, but we're given something in units of ounces. You need to know what those are, and those are typically given to you. The third piece, and this is sort of where we tie together math and chemistry again, is there's chemistry relationships. There's an almost limitless number of chemistry relationships that we can have, but a key sort of strategy to help you think about how to solve these problems is think about somehow trying to walk to moles. You can think about moles as sort of being the central hub in doing unit conversions, because if you walk to this central hub of moles, it's often easy to walk someplace else. So, and that's often a way that you might be able to get partial credit for a problem, is if you find some way to get to that central hub of moles. Okay, so that's just a little bit about the kinds of problems we're likely to see when we do math in chemistry. But I want to take a second and just remind you about calculator use, and importantly, thinking about how to do scientific notation in your calculator. So scientific notation. And importantly, if you are not using this EE button on your calculator, if you are typing something in as the mathematical time symbol, and then the numerical 10, and then the caret symbol, and you are wasting time and are very likely to be getting the wrong answers. So let me give you an example, and let's talk about a number that we're going to see a lot in chemistry, Avogadro's number. Okay, Avogadro's number is 6.022 times 10 to the 23rd. Okay, and if we again go with our philosophy that we had before, we never want to write a number without a unit and a qualifier. This is the number of entities and per mole of something, right? And it's mole of anything, right? We could have moles of water. That's the example we're going to give in just a minute. So I'm going to highlight that there's two ways you could think about putting this quantity into your calculator. And I'm going to highlight that one of these is the correct way, but I'm going to highlight that many people are probably doing the incorrect way. So how you want to enter this into your calculator is 6.022, some way of using whether it's EE, and I'm going to show you three different calculators that'll show this. One of these has an EE button, another one has a EXP button, and then another one actually has the mathematical times 10x. But you want to be entering this in this way in order to make sure that you get the right number. So I'm going to show you this with this calculator. So again, this calculator, I'm going to type 6.022. So I type in those numbers, and then I'm going to use this key right here. That's going to say E, and then 23rd. So that's what this one looks like on this calculator. Okay, this is one of my favorite calculators because it's very easy. It's very easy to access this, this button here. I'll put a link for this where you can purchase it. This calculator is usually around $12, so a pretty simple calculator. But again, if I just type equals, you'll see that I get the right number in terms of scientific notation as it appears on my calculator. Okay, I'm going to show you how to do it on this guy too. Okay, this one's a little bit different. I don't love this one as much because the EE button is actually like above the the inverse symbol, and so you actually have to use this second button, the second function, in order to get there. So if you have a calculator like this, you're going to type in 6.022. To access that blue, you can see the EE is above there. That means it's one of these second buttons. So I have to type second, and then I have to type E, okay? And then I'm going to type in 23rd. So looks the same as I did on my other calculator to start with. Okay, a little bit more involved to sort of get there. And if I type in enter, I can see that it looks the same on my calculator, 6.022, and then I can see that 23 sort of as an exponent there. Okay, so that's that calculator. Again, I don't love this one as much. Again, highlighting how I do that, 6.022. I have to do the second times 10 to the, and then 23rd. Okay, so a little bit more work on this one, but that's how you'd use this one. This one is pretty straightforward because the button that we have on our calculator actually says times 10 to the x. So for this one, you literally just type in again 6.022. And then when I type that 10 to the, when I hit this button, notice that my screen display shows E as well. Okay. And then I'm going to enter 23rd. Okay, so again, if I just type enter with that, it's going to report back what that number is. You'll notice that this is what you type into the calculator. So type in your calculator, and then this is what you see. And in all three of these cases, what your calculator is going to show you is 6.022 E, just a single E, 23rd. Okay, so that's again what's shown here. Now with these other calculators, what it looks like in terms of what you see on the screen in terms of an answer, I don't see the E, but I definitely see that that 23rd is a superscript. Okay, so that's going to be 6.022, and then it's sort of superscript. So for both of these calculators, that's what I see. It's important that you not only know how to put stuff into your calculator, but then you know when your calculator gives you an answer, what that means, okay? So I'm going to give you a sample problem here, and I want you to envision a bottle of water right here, okay? Because I also want you to always have a logic hat on when you are doing sort of problems. So before we get to that problem, let me just highlight how I think many people are putting this into their calculator. So again, I'm going to say that this is incorrect. Now, sometimes you might get the right answer, and I'll highlight it's probably a simpler problem, but what people tend to do, for example, with Avogadro's number, is they will type in 6.022. They'll use the mathematical times symbol. So this is the math operation. And then they will type in the number 10, and then they'll use the caret symbol, which is a symbol for an exponent. Okay, and then they'll type in 23rd. So again, I've got, so for example, there's a caret symbol that we have there. And so if I just type in 6.022, and then I do the mathematical time symbol, and then 10, and then I do a caret and I type 23. I want to show you what this looks like. 6.022 mathematical times the number 10, then caret, then 23. If I say enter, it still gives me the same answer, okay? So I still see this, but a couple of things. It probably took you a lot more typing to get this number in, and here is why this is going to be problematic in the future. Your calculator is recognizing this as two separate math operations, okay? It's recognizing this, for example, as the number A, and then you are multiplying that times this number B, okay? And why that's going to be a problem is when you start multiplying multiple things together, if you don't put things in parentheses, you might think something's in the denominator, but your calculator is putting it in the numerator. Okay, so if you've ever had a problem, and I'm going to go through an example here, where all of a sudden you get like a ridiculously large or a ridiculously small number, it's probably because of this. So not only will you never have that issue happen if you enter something in using the correct scientific notation button, but it's also going to be way easier. Like legit, think about how much time it took to sort of have to type all that in. And then if I need to put it in parentheses too, and I know many of you are doing it. So I want to early on sort of break you of that bad habit. This is like learning how to type, right? If you're a single finger typer, it's painful for a little bit to learn how to type with all of your fingers. But once you get through that learning curve, you will be able to type so much faster. The same is sort of true here. Okay, so I want to go through a practice problem and then sort of have you sort of see if you can get the right answer. So here's the practice problem, something fun to think about. What volume of water would contain 1 trillion water molecules? That sounds like it's a lot of water molecules. So what volume of water, and I want to know it in gallons. What volume of water in gallons would contain 1 trillion water molecules? Okay, so here's how we want to think about doing this, and this is a perfect sort of example for us to sort of highlight all these different places where you could enter something wrong into your calculator, sort of use the wrong sort of piece of information. So, and I'm going to highlight where we get different pieces of information. So let's say 1 trillion is 10 to the 12th water molecules. Okay. Here's a classic place where students can make mistakes. So any place that's sort of a mistake piece, I'm going to sort of highlight in red here. 10 to the 12th is really 1 times 10 to the 12th. Now, if you type in, oh, Dr. Pretty showed me how to use that E button. I'm going to type in 10 EE 12. Don't do that. If you type this into your calculator, what you're going to get is that's thinking you want 10 times 10 to the 12th, which is really 1 times 10 to the 13th. That is not the right math, okay? So again, if I'm typing this number in, I'm doing it right, I'm going to say 1 times 10 to this. I'm going to enter my exponent, and then I'm going to say 12, okay? So 1E12 is really 10 to the 12th. So again, the correct thing, if I enter in 1E12, that's going to give me the right number, okay? And it's 1 times 10 to the 12th. We don't see that times 10 to the 12th. Okay, let's keep going with this sort of problem because I'm going to need to use Avogadro's number. I'm going to know that 1 mole of water is 6.022 times 10 to the 23 molecules of water. So 6.022 times 10 to the 23rd molecules of water. Okay, and highlighting, I'm going to be religious about this when I do this. Like every species that I have is going to have a value, a unit, and a qualifier, who it belongs to. Always have those different pieces, right? So here's Avogadro's number, classic way that students can make mistakes, again, is if they put this in wrong. We want to make sure that we are not using, so do not use the times symbol. Do not use the caret symbol. You should not need to use parentheses. Again, how you're going to type this in, 6.022 E23. Okay? Let's keep going just with this problem. I know that 1 mole of water, okay, is 18.02 grams. And then, so again, this is molecular weight. That's something that, again, you should know, right, at this point in chemistry. And then we're going to have a unit conversion. That is something that's probably something you've seen before. 1 gram of water is 1 milliliter. You know, I'm going to back up here. I want to stop here because I want to have something that's sort of meaningful for us. I told you, here's a bottle of water here, right? This says it's 16.9 ounces. Let's back up for a second here. Let's not have this in terms of gallons. Let's have this in terms of milliliters. So I want to have this in terms of milliliters. Let's run through this calculation, okay? You maybe pause and do it yourself. Let's see what the answer is that we should get. 2.99 times 10 to the minus 4th milliliters. Okay, so this is 0.000299 milliliters. This is 0.299 microliters. Now, I don't know if you've ever used like pipettes before. Pipettes can pretty much go down to about 1 microliter. This is probably what 1 microliter, if I were to put a microliter of water on my sort of iPad, it kind of looks like the tiniest little drop of water. Okay, so I probably could see a water droplet that contains 1 trillion water molecules. But let me highlight what people are likely to get if they do not put this right into their calculator. Okay, so I'm going to show you. Let's imagine that I did the 10 to the 12th right, and I said 1, and I'm going to use like the bad way of doing it. Use sort of these caret symbols. What if I entered in like 10 to the 12th, right? That's 1 times 10 to the 12th, and then I said I'm going to multiply that by 18.02, right? So that's what that looks like, times 18.02, and now I'm going to divide. And I'm going to do this the wrong way, 6.022, and then I'm going to say times 10 caret 23. And you can't see everything here, but I'm showing you that I entered in Avogadro's number using the way that I told you not to do it, this way, okay? This is going to give me an answer that says 2.99 times 10 to the 35th, okay? So if you did this incorrectly, okay, you will get 2.99 times 10 to the 35th milliliters. Now, maybe you didn't know, maybe 1 trillion water molecules sounds like a lot, and you're like, well, okay, that's fine. Here again is the problem that is happening here. I'm going to move this, just give myself a little bit of room down at the bottom here. Okay, here's what's happening, and I'm going to use some colors here to highlight that when we're putting this in our calculator, here's a value, here's a value, here's a value. If you're doing this the wrong way, and then there's a, oops, and then there is, let me do blue here. There's a value. So if you are doing this sort of the wrong way, you are going to have A times B. What you want to do is divided by C times D. Let me color code these here. Oops, wrong color. A was my 10 to the 12th times B, that was my 18.02, and divided by 6.022 times 10 to the 23rd. If I just type this into my calculator, here's what your calculator thinks you want. So calculator thinks you want A times B divided by C times D. It's putting that D in the numerator. Unless you actually, and some of you may be doing this, unless you're putting that in parentheses, you are going to get the incorrect answer. You're going to get this answer here. So I just want to do another little piece of unit conversion just to sort of show you. I want to do two other problems. If you feel like you're fine with unit conversion, then you don't need to watch the rest. If you're like, I got it, Dr. Parenti, I know how to use that correct function on my calculator, right? Know how to do it here. I want to just kind of highlight and just show you the absurdity of this number. I want you to see how many gallons that is, and we're going to compare it to the volume of Lake Erie, okay? So let's sort of go do this. Let's imagine we're going to take that 2.99. So again, this is the wrong answer, but let's convince ourselves that it's wrong. 2.99 times 10 to the 35th milliliters, right? If we thought that that's the amount of water that we'd have to have for 1 trillion molecules of water, I'm just going to show you some unit conversions. Here's a prefix conversion. So I'm converting milliliters to liters. And here is, again, English to metric. You wouldn't have to know this. So again, this is a prefix conversion. Here's another English to metric. This would be, math for this is going to be 7.899 times 10 to the 31st gallons. This is 600 trillion times the size of Lake Erie. Okay, not enough water there. Let me show you another unit conversion. Let's just imagine, and this is totally a fair game problem for a chemistry question. I was just to ask you how many molecules of water are in this standard water bottle, okay? So just walking through sort of how we do this, 16.9, this is a 16.9 ounce bottle of water, so 16.9 ounces of water, right? I need to convert ounces to milliliters, so that's one of those English to metric conversions. So 29.5735 milliliters. Now I'm going to use that same density conversion. A milliliter is a gram. Now I'm going to use a molecular weight. And then finally, Avogadro's number, 1 mole of water is going to contain 6.022 times 10 to the 23rd molecules of water. So highlighting again, if you want a little practice on unit conversion, this is an English to metric. This is density. This is molecular weight. This is Avogadro's number. Some of those things you'd need to know, some of them you don't, but practice going through and doing this calculation. Okay, go and do this calculation correctly. You're going to get 1.67 times 10 to the 25th molecules of water. Remember, we had asked about 1 trillion. 1 trillion was 10 to the 12th. So, wow, there is way more than 1 trillion molecules of water that's in here. Now, I actually didn't give this problem as sort of the sample problem to try. Here's why. The number that you'd put in scientific notation is in the numerator already. The problem tends to come when you're putting numbers that are in scientific notation in your denominator, and you don't put them in parentheses, or you don't use sort of the correct function, the EE function. So what I hope I can do in this video is break a really bad habit that's going to take you more time than you need, way more time than you need, and potentially set you up for making mistakes. Learn how to use the EE button on your calculator. Come see me. It literally will take about 90 seconds for me to make sure to show you how to find that button and use it correctly on your calculator.